a poll up. All right, so there's a, there's a slight edge, I guess, for iPhones. 6-1. Anyway, we finished up chapter 10 last time. It was a big chapter on how do we create apps in a more object-oriented manner by thinking about what kind of objects we need in our app that aren't supplied by Java. What ones can we code to represent things in our system, like customers or pizzas or anything else that you can think of that would be the foundation of something you needed in an app that you're writing that isn't a built-in, say, UI element in Java or one of the other couple thousand utility classes, but is something rather that is specific to your business scenario that will help you manage objects of that type in your app. All sorts of advantages to doing it that way, but one of the things that's always struck me about this is from the user standpoint, I could put two different apps up on screen that looked identical. And if you want an example, you could think back to the Pirate Customer report, the first version and the second version. Although just because I've been inconsistent a little bit with the UI, there are differences. The first one uses integer points for the point club, and I think just calls it the point club. And then the second example uses double decimal numbers and calls it the booty club. So if I showed you two screenshots or two running examples of those, you could tell the difference, but I could fix those minor inconsistencies. And the difference between the integer and the doubles is actually somewhat intentional, and we'll get to why later. But my point is, I could put these two apps up on the screen or two other apps, and you could look at them and you would not know under the hood, is one of them using objects, in the manner in which we're describing? Has one of them created pirate customers and filled up, the UI with pirate customer objects? Or is it all done, using separate arrays of strings and integers and whatever else may be needed to manage these customers? And so people always expect there will be this huge change that'll be obvious to everyone when you code it, in this more object-oriented manner, and it's just not. There's no necessary thing that happens on screen that's going to tell you, oh my gosh, this is coded really nicely in a really nice object-oriented manner under the hood. You don't know, and so it does leave people thinking, well, that's seems like a lot of work, maybe for me to put into this when you can't tell the difference. And so last time we talked about, well, the part of the payoff is, your code is going to read much more easily. Anybody else working on it, if you've coded it in a really nice object-oriented manner, anybody else should be able to step in and understand what you've done and make fixes, make extensions, make adaptations, corrections, whatever the case may be, to your code, collaborate with you on your code easily because it will be so easy to read and work on, we hope. And again, that may not be a compelling reason for you to do this. You may say, well, I work alone. I'm not going to be collaborating with anybody. I just want to create, this app and get it working correctly, and no one will be analyzing my code. It won't be graded maybe, so why would I why would I go all in on this approach, in that kind of a scenario? And the answer is there's a whole nother payoff that we haven't talked about yet, and that's what we cover in chapter 11, which is inheritance. So maybe the biggest payoff is that we can use classes that we've coded, like, say, Pirate Customer or Pizza, and we can use them as the basis for new classes that we create, typically classes that are close to, related to, you might say, the class that we've already coded, but that needs some changes, some adaptations, some fixes, whatever the case may be. We need something like a Pirate Customer object, but it's different. And so we ran into this a little bit last time, in that we had the pizza class that was great and that we were using in some of the point of sales, and then we wanted to add this feature that was a % discount based on your loyalty club membership level. Gold you might remember, got 50% off. And we still make money on that because of the quality of the ingredients that we use in the pizzas. But I said, it's not really the royal we, I said, you could add that discount just by going into the pizza class and modifying it. But there is a reluctance to go into working classes and make those changes. Last time, I created a whole new class called, discounted pizza or something like that to make those changes too. If we had known about inheritance, then we might have been able to use this approach as an alternative. So inheritance is creating a new class, but basing it on an existing class. This creates a superclass subclass relationship, and the subclass creates or inherits the properties of the superclass with some important limitations that we'll get to in the chapter. But the idea is, when you use inheritance, you get a lot of code that's already been written, hopefully, and tested. It may even be in production, under active use, something that you feel like you can rely on as a basis, and you could use inheritance to start out with all of that work without having to recreate it. And this has been something of a holy grail for software development is how can we make code that's been written easy to reuse. There's always this sense when you're writing these apps that what you're writing can't be all new. It can't be the first time anybody's thought to create a customer or whatever the case may be. But there's no easy way to reuse other code, even in your own organization. Somebody else may have written an app with a customer, but it may not be in the same language. It may run on a different platform. It may not have been coded, in an object-oriented way. So, but that's what Java gives us to some extent, is this package of benefits, which is if your organization's using Java, then there's a good chance that this other app that was written maybe by somebody else or by yourself years past, what is written in Java and is object-oriented and will provide you an easy basis to inherit from, to start from. Anyway, that's part of the coolness. The other part of the coolness is what I talked about just a second ago, which is this reluctance to get into a class that's already been working and tested and make changes to it. You might have already had this experience in your own homework or exam work in which you had something working well, and then you made a minor change that you thought was not related to a feature that was working, and all of a sudden the feature stopped working. And that happens to almost everybody. If it has not happened to you yet, then be on the lookout for it. Enjoy it when it happens. But as it happens to us as we work, it makes us reluctant then to make those kind of changes to something that's already working and already tested, already certified, already in use. Jumping in there and making a small change could have unintended consequences that are difficult to predict and sometimes difficult then later to track down and fix. So programmers have this reluctance to jump into this previous code that they've already written and already put out and then start making changes to it. And inheritance gives us this option, this other option, which is don't touch the original class. Don't touch the pirate customer class. Don't touch the pizza class. Instead, inherit from it and then add what you want to add that's new or different or is an addition or a fix or whatever the case may be, but don't touch the original class. And that way, apps that use create objects of that original class type are not affected by your change because you haven't changed the superclass. You've left it alone. I had a textbook at one point. It implied that, well, as a budding software developer, of course, you would only ever use inheritance. It's the only way, the only correct path to take. And I always have taken issue with that. I think it's fairly obvious that for simple classes, it might well be easier just to go back in. If you have an obvious bug that needs to be fixed and fix it, that may be by far and away the better choice. So don't blindly jump into something and think, oh my gosh, I have to use inheritance because it's this feature that, I learned about and is awesome and therefore I have to use it. That's not necessarily the case at all. And in fact, in some of the examples today, we'll use inheritance to do stuff that I probably would not use inheritance if I was actually working on it, in a non-teaching kind of scenario. All right, so the magic word, there's just one keyword in Java which triggers inheritance. And the thing is, not only do you already know it, you've already done it. The keyword is extends. There we go, extends. So hopefully you're thinking, hey, wait a minute, I've typed that. I've typed it a lot. Every GUI app that you've written in your public class declaration, you've said public class my app, and then you've said extends JFrame. Extends triggers inheritance, and it says that your app is a subclass of JFrame. That is, it inherits all of the features of JFrame, which allows it to show itself in a window and be the basis of a GUI app. We get everything we need to out of JFrame and then just add what makes our app our app. And we've done the same thing with JPanels. Every time we created a custom JPanel, we said class my add panel extends JPanel, and that allowed us to create types of JPanels, subclasses of JPanels that did our drawing but inherited all the features of JPanel to make our drawings work better. You can add features to lots of the built-in Java classes. So as an example, we've used JTextAreas a lot to produce these reports, PirateCustom reports as an example. And one of the things that's kind of annoying is that the JTextArea does not have, it has an append method that we use to tack text onto the existing text in the JTextArea, but it doesn't have append line. So every time we append a line of new text to say our report, we have to also then append on the /n character to get us to a new line. It's kind of a stupid omission, and it's actually pretty easy to create your own type of JTextArea that adds an append line method. You can't do that to every built-in Java class, but a lot of them you can, which means you can leverage all of those thousands and thousands of classes in Java and customize them, deeply, more deeply, to make them work the way you need them to work in a particular app, say. All right, here's the syntax, and again, this should not be a huge surprise to you. We use the keyword extends, and on the left and on the right there are two class names. So class name 1 is the superclass, class name 2 is the subclass. So everything we've been doing in terms of our GUI apps have been extending from JFrame, and from the standpoint of our custom panels, it's been extending from JPanel. We've created subclasses of JFrame and subclasses of JPanel to take advantage of all of the features and functionality in these built-in classes. But we can do it with our own classes as well. So I'm going to start out with just a much simplified version of the Pirate Customer. So this Pirate Customer just has the attributes that we need, so their name, the point club level, which I've made a double here, and then the membership level text. So I've gotten rid of the get membership level method and any other methods that made Pirate Customer complex here, and just boiled it down to the very simplest Pirate Customer that we might have. And so it might be the case that a restaurant has come along and said, well, we're adding a new feature for our Pirate customers, which is their Pirate rank. There's at least 5 or so different rank options, depending on how much experience you have sailing on boats like that. And so the lowest is the Swabby, and the highest is the Captain. So let's say we wanted to add this feature. Management comes along and says, you gotta add this rank attribute to our Pirate customers, and you're reluctant because you've already got Pirate Customer working correctly, and you don't want to just jump in and make changes, but you can use inheritance to add that feature without touching Pirate Customer. And so the screenshot of inheritance example here is an example of doing just that. So you can see below Pirate Customer, I've created a second class called RankedPirateCustomer, and I've identified Pirate Customer as its superclass using the extends keyword, the magic word. And then in RankedPirateCustomer, there's just one line of code. It says string rank string equals Swabby in quotes, semicolon. So all it is a variable declaration and initialization. There's one line of code. And so by itself, RankedPirateCustomer doesn't look like it would work because it's missing key features that we needed. But by identifying it as a subclass of Pirate Customer, it gets those 3 variables, attributes, and declarations automatically. As soon as a ranked Pirate Customer object is created, it gets name, booty points, and membership level, and rank. So from a UML standpoint, you would lay it out like this. You use an arrow pointing to the superclass from the subclass. Okay. So there's the arrow that I'm talking about, going from RankedPirateCustomer up to PirateCustomer. And again, RankedPirateCustomer via inheritance gets those 3 attributes in PirateCustomer. All right, awesome. Overriding. It is possible, maybe even more than possible, that when you're creating a subclass and you're doing so on a class, the superclass is something that you've written, you're creating a subclass, and in at least one or more cases, you'll need to replace something. You'll need to fix something that's in the superclass that you want to work differently in the subclass. And it could be a glitch, or it could be just you've changed policies and now it needs to be different. Whatever the case may be, but you need to make a switch or a change to something that's in the superclass and do it differently in the subclass. And we would do that by providing a new attribute or a new method declaration with the corrections as we want them to be. So we would create an attribute of the same name and data type but set it differently, or we would create a method with the same return value, the same method name, the same parameters, but do different things inside the method. And it's when we actually do it, I think it'll make sense. I mean, I'll do it in some ways that hopefully do make sense. And the technique here is called overriding. So you override something in the superclass by replacing it in the subclass with something with the same declaration, but that is different in terms of how it's operationalized in some way. And so overriding sounds a bit complex and object-oriented, but it really is, I think, especially when you see it in action, I think it's going to be exactly what you would expect. I mean, if you're writing a subclass and you provide something that is clearly replacing something that already exists in the superclass, you're doing it because you're making changes to it and you want your objects created from this subclass to have your changes. That's why you're replacing this method, is because it needs to work differently for objects created from the subclass. So you want it to replace, or the term is override, that duplicate method or what appears to be a duplicate method that already exists in the superclass, and instead use the one that you've changed in the subclass. I think it's going to be kind of obvious that is just what you would want. It is also a little bit confusing because the word sounds an awful lot like overloading, right? Which we learned about in chapter 9. Overloading was providing methods with the same name but different parameter lists in the same class. And we've done it in a couple of cases, but it's common to overload the constructors to provide a constructor which takes different parameters so that you can easily create objects of your class type flexibly. That's overloading. Overriding can deal with methods, but also can deal with objects or attributes, as well. Overriding deals with making these sort of apparent duplications in a superclass-subclass relationship. So providing methods, for instance, with the exact same name and the exact same parameter list in a superclass-subclass relationship is overriding or replacing. Overloading deals with a single class. Overloading deals with providing methods with the same name and the same parameter list in a single class, so that when you call it, you have these multiple choices. Overloading provides you with these multiple choices in the same object. Overriding deals with, how do I fix or replace something in a subclass that needs to be changed in the subclass, but that's already been defined in the superclass, so I need to do something to override it or replace it. So the terms do seem very similar, and I know students frequently think it'll be confusing. In practice, I don't think it is in most cases. All right, an example would be this PirateCustomer and RankedPirateCustomer example we just talked about. So I've got this simple PirateCustomer which has name as a string, the double booty points, and the string membership level. That's the simplified, very basic PirateCustomer. And then we just talked about adding the rank in this subclass, RankedPirateCustomer. So rank does not exist in the superclass. So it's not an example of overriding or overloading since it's not a method. So but let's give an example. Let's say the policy changes. Management realizes these double precision point club, values are silly. We really just need to use whole numbers, integers, and they say go ahead and change that. So you could do that in RankedPirateCustomer by overriding this variable booty points. So you can see in my subclass there I've got int booty points, whereas in the superclass I have double booty points. This is an example of overriding. If you create a RankedPirateCustomer and set a value on booty points, you have to give it an integer. If you create a pirate customer, they'll stick with the double. They'll stick with the double precision decimal version. So the attribute name is identical. What's different is I've essentially corrected the data type, if you will. I've made this change to the data type. And in doing so, I'm overriding the older version in the superclass. So importantly, when I do this in RankedPirateCustomer, I haven't changed anything in PirateCustomer. It doesn't change PirateCustomers' double precision version. They still have a decimal version. So any code that's been written using PirateCustomers, they will stay PirateCustomers. They won't be in some way changed. They won't lose their decimal values. These changes here do not affect the superclass. And again, that's considered an advantage. By leaving PirateCustomer alone, we know we haven't broken any apps that use PirateCustomer. Instead, we're laying the groundwork for creating new apps or adding features to existing apps that might use RankedPirateCustomers. And these objects created from this class will have these changes, these additions and these changes. All right. I downloaded the new resources, I unzipped it, and then I've opened up Chapter 11 Inheritance, and it has some examples in there, including PirateCustomer Report 2.java. So let me switch to Eclipse, and I'm going to set up a new project for Chapter 11 and import this stuff that we want to use for today's and next week's example. All right, so okay, so I'm going to create a new Java project. I'm going to call it Chapter 11. And I'm expressly not going to create a module. And then to import stuff into Eclipse, I'm going to drag and drop it. But you'll notice I have some PNG resources, and I don't want those going in the same place. So I'm going to resort my folder by the kind of file it is. And then I'm going to grab the source code files and drop them into the source folder inside of Chapter 11. And double check that they are there. And then I'm going to grab the images and drop them on the project folder, Chapter 11. And you can see they show up right there. Normally, I write the code so that organization will work. You can write the code differently so that the images will work inside of the source folder. So it just depends the way you load the image, which location works. The way that DrawTool writes it, you want them in the project folder. All right. I do have this activity up from last time that we worked on with teammates, and we will actually come back later in this chapter and update teammates also using inheritance. So that's why it's here. But what I want to look at is PirateCustomer Report 2. So let's run it. This one does not have a graphical interface. It's all done at the console, just because I've simplified PirateCustomer down to this almost useless simplification. And then here's RankedPirateCustomer. So this is exactly the UML we talked about. The 3 attributes in PirateCustomer, the new attribute rank in RankedPirateCustomer, and then the overridden booty points. So it's overridden because it has the same identifier. It is a variable in the same scope. They're both instance variables, and they have the same identifier. So they would, if they were in the same class, they would conflict with each other. But because we've done this in a superclass subclass relationship, there's no conflict, but there is replacement. RankedPirateCustomers will get the integer version, whereas PirateCustomers will get the double version. All right, so the example then just creates objects from each. So you see right here, I hope this is big enough. You see right here I'm creating Pirate Customer 1 P1, and he or she is a Pirate Customer. And I give them a name, Sven the Merciful, doesn't sound very intimidating. And I give them a point club balance with a decimal point, and I declare that they're a gold member. Sven's in good standing. And then I create a ranked Pirate Customer P2. So P2 gets name, gets, and so this is for Sven's brother, gets the integer version of the point club balance. So I give Sven's brother 31, they get a membership level silver, and they also get a rate. They are a mate, which is higher than a swabby, so that's good. And then just to test that this is working, I do some system out print lines. So the two are p1.name equals and p2.rank equals, and you can see them in the output. P1's name is Sven the Merciful, P2's rank is mate. But then that opens the door for some stuff that we can't do, right? I can't set, so I've got this commented out, but let me uncomment it so that you see it in glorious color with the red underlining. So if I try to set P1's rank to captain, well, we can't do that. We get an error. So let's hover over it and see what the error is. I know this is probably too small for you to read, but it just says rank string cannot be resolved or is not a field. And that can be confusing because we did absolutely create rank. It's right there. It's in the same source code file. So if it's going to throw people, it throws people because of that, because they look down and they say, well, I absolutely created that attribute. Why on earth is this not working? And it's not working because P1 is a pirate customer. P1 is not a ranked pirate customer. Pirate customers do not have the rank attribute. They are not rankable. So I can't assign them a rank. If I want a pirate customer that I can assign a rank to, I need to create them as a ranked pirate customer. Is the bottom line. That's just not going to work. And then I'm trying to set P2's booty points. I'm trying to give them a few more. So they had 31, and I'm trying to boost that up to 33.85, and let's hover over that. This will give us a slightly different error, which is type mismatch. Cannot convert from double to int. Okay, so this is an error because P2 does not have the decimal version of booty points. That's not what it has. It has the integer version. And you're trying to give it a double value of 33.85, and then we've got a data type mismatch issue because Java's saying, wait a minute, if I were to do that assignment, you'd lose the 0.85. The integer variable you're trying to do this with cannot accept the 0.85, and it can't promote 33.85 to a different data type to make this work because double's the highest value data type. To make this work automatically, Java would have to demote this double value to an integer value, and once again, Java will never do that. So if we really want that assignment to work, we have to say, recast as an integer this value, or obviously not type the 0.85 or round it. If you were writing this in code and you had to make this work, you would probably round it, decide to use math.round to round it up or down, and then recast the result as an integer, something like that. All right. So that would be a way to make that work as well. Okay. Some people think that when you subclass, when you use it as a superclass, and you provide these sort of corrections or replacements, that in some way invalidates the superclass, like that now you can't use the superclass. And that's not the case at all. In this example, I have these two classes, PirateCustomer and RankedPirateCustomer, and I can still use both. By creating RankedPirateCustomer, it doesn't in some way say that PirateCustomer is now unusable, that it's expired or something. It's still perfectly good to use and may in fact be used in other apps, for some time. All it means is we now have a new class that we can use to create slightly different objects that may be handy. Okay, I think we'll come back to the rest of this, but just as a little bit of a preview, the other thing about this that's interesting is that PirateCustomers and RankedPirateCustomers are related. RankedPirateCustomer is a child of, or a type of, PirateCustomer. That'll have implications in terms of how we write our code, in that we can, for instance, treat them as the same type of object because of that relationship. So we can do stuff like put PirateCustomers and RankedPirateCustomers into the same data structure because they are ultimately the same type of thing. And Java will let us do that. but then it will introduce some complications or wrinkles that we'll talk about later. Okay, let me switch back to the keynote. That was PirateCustomer 2, but again, we will come back to some additional wrinkles in PirateCustomer 2. All right, the team member example. I always like to, if possible, do some typing instead of just showing you code that I've already typed in and that already works, because I think people also learn just by seeing it evolve kind of line by line rather than seeing it all evolved all at once. So if you've been following along and you get something out of following along, then this will be your follow along opportunity here. What we're going to do is we're going to add a feature to TeamMember called pawPrintsBalance. And I want to add that feature, but I do not want to change TeamMember. All right, so TeamMember is already in use in several very important apps used on campus. So I'm making that up, obviously, but assuming that it was, I don't want to make a change to it because that could break code that's currently running. But I want this feature for something I'm working on, and I might want to use it down the road in other new apps that I'm using, or later, once it's tested, I might want to go back and revise existing apps so that they use TeamMatePros instead of TeamMember. So I'm going to create a subclass of TeamMember. I'm going to call it TeamMatePro, just because that was the best name I could think of. And then we want to create a report based on TeamMatePro objects. And I say in the activity, you could use a text area, a JList, which is still kind of new to us, or the console, and we'll just focus on the console. So I'm going to switch back to screen sharing. You should see my Eclipse again with PirateCustomer report open in one tab, and then the activity tab open, which has got this activity we did last time. So this uses our teammate class. It has a single constructor that takes the 3 attributes as parameters to initialize the 3 attributes. And all the app did was create 3 teammates, Joe, Pat, and Aaron, and then produce this little report to the console. Sorry, let me run it so that you, apparently I didn't fix the tabbing. So I want to kick major over a little more. So I've got 2 tabs, and then I'll throw in 2 tabs. All right, let's see if that fixes it. Well, I'll need to work on that some more. Let's start with something that at least kind of works. Yeah, these tab reports are sometimes a pain, and you have to, in some cases, to get them to really line up, you have to add additional spacing using some if statements to get the tabs to work nicely. You can also, in Java, you can redefine how many spaces are in the tab character. So in some reports, you end up just being able to say, well, all right, if we make the tab 8 characters, then everything works beautifully, and that's an easy fix. And obviously, to make this work better, you also would need to round numbers like this so that the subsequent columns would line up correctly. In any case, maybe I'll just take the H off here, see if I can. It just bugs me that they don't line up. All right, then we'll get rid of this one. And the GPA would need to be rounded, but this should give us pretty much a rounded up report. Okay, so taking this as a starting point, I want to add a feature to teammate, which is a new attribute, pawPrintsBalance. And this is where I'm faced with this choice. I could literally just in teammate start typing and say, int pawPrintsBalance. But as I do that, I'm also thinking, wait a minute, this is going to change existing apps that use this. And it could be maybe some existing apps that use this already added a pawPrintsBalance to the app because they needed it, and now providing it here might break that. So there's definitely, there should be a degree of reluctance in here to start messing with a class that's already in use, has already been tested and qualified. So I'm not going to do that. I'm going to use inheritance. So inheritance will be carried out by creating a new class, giving it its own name, so TeamMatePro. And I'm going to identify the superclass using the keyword extends. Okay, and I'm getting an error here simply because I have not provided a constructor. And teammate identifies its attributes but does not initialize them. So that means a constructor is required to make that work. So I could cut and paste that down there in some way, but the easier way to do it is just to create your constructor and then define it to take the attributes that it needs to take. We could start out with the 3 attributes that we've got, and then we could call the constructor in the superclass and pass it these 3 values. So let me explain what we did, because it can look a little bit weird. Due to the way that I coded Teammate, it requires a constructor. And so its child, TeamMatePro, has that same requirement because it does not initialize those variables. So there's multiple ways to fix it, but the bottom line is I have to initialize those variables. And to some extent, I'm assuming that I still want this constructor where I can pass these values, but that's an assumption. I could instead have a default constructor that initialize these to some starting value, empty strings and a 0 GPA, something like that. Since we already decided that a default doesn't really make sense, and we instead want to be able to set it up when we create objects of that type, then I'm going to stick with that design decision. Okay, but the key thing, the thing that we're actually trying to add is we want a new attribute in TeamMatePro. And it is this double value, and it is pawPrintsBalance, something like that. And so I'm not going to initialize it. And the issue then is, now how do I set it? I don't want it in that constructor. To me, it probably makes sense that you'd want to add it to the constructor. I'll call it PPB. So I'll say pawPrintsBalance equals PPB. All right, so if that order works right, we should be able to create new TeamMatePro objects, pass them a pawPrintsBalance, and have that correctly initialized in their object with whatever value we pass it. So let's try that. But I really want this to line up a little better. So I'm going to change these random numbers just to data. So that I can have this extra column. And then I'm going to add some new objects. So I'm going to give myself some room. And then I have to give it some data. So I need a short name. Fairly short major for this to work, GPA, and then I need a pawPrintsBalance. So obviously, if you're following along, please feel free to select your own names and values. Nothing in terms of what I'm declaring makes any difference. But if you're following along, what you should have is your array expanded with 2 new objects that are TeamMatePro objects. And their only difference is they have this last attribute, which is their pawPrintsBalance. And so then I want to look at their balance. So just really quickly, we could look at an individual's balance by saying, whatever, Jack's balance equals, and Jack is team 3, and I want to get their pawPrintsBalance. Right off the bat, our first glitch here is that the array has been defined to hold teammates. So by default, it views team 3. I've given this a bad name. I realized that after class last time. These individual objects aren't teams. So the name team is kind of stupid. These are each, let's say, students. So I don't know if this is smart to rename it necessarily or helpful, but if you're being to some extent thrown by that poor naming choice, it doesn't like that because of the syntax errors. What syntax errors? Oh, so I've still got refactoring will sometimes refuse to do it if you have a syntax error. So obviously then you'd want to correct the syntax error or comment the line out. So I'm changing the array to be called student instead of team, because each of these elements are individual students, they're not individual teams, so the name didn't really make any sense. But a ramification of this is, because I commented this out, you'll notice refactoring did not change this one. So refactoring does not change code that's commented out, which I think makes sense, but you got to remember, anything you have commented out won't get refactored. So it's just one more thing to think about before doing a refactoring is, wait a minute, do I have any chunks of code that I've commented out for one reason or another that I want to comment back in for the refactoring and then comment back out after the refactoring? So now if I comment this back in, there's still a syntax error on the dot because there's not anything after it. Now there's another syntax error because it says team, and there is no array called team. So now I've got to fix that manually. Student 3. So I have access to, but you and I know student 3 is a TeamMatePro object. So I can recast it. I don't know why I capitalized the M sometimes and not other times. This requires more parentheses than I might like, but in the end all I'm doing is saying that I know student 3 is a TeamMatePro, so in that case I should have access to everything in TeamMatePro, so by recasting it, now I do, and there's pawPrintsBalance. In production, that's not how you do it, because you wouldn't necessarily know which students were teammates and which were TeamMatePros. So you'd use an if statement to figure that out, but this is how we would access additional attributes in TeamMatePro objects that don't exist in teammate objects. So if we tried to access pawPrintsBalance in student 0, 1, or 2, we'd get an error. But students 3 and 4 were good to go because they actually do have that added attribute. So just to run it to show you that it works, there's Jack's balance in the console. So if we wanted it in the table, we could add it as another tab, and then we would just need to be a little more sophisticated in here. So I need an if statement, and I need to know if correctly typed student J, if they are a teammate, and that's the syntax to do that, or I'll write it all the way out. I'm going to double check that student J, oh, I screwed that up. I want to just double check. If they're a teammate, I'm going to use this existing system out print line. If they're not a teammate, then they have access to, I have access to this other piece of data. So I'm going to, let me reformat these so that you can actually see everything. And I'll do it up here too, just so that there's commonality as you look up. Okay, so for TeamMatePro objects, I can add on this. But I'm going to have to use the same syntax. I'm going to duplicate this up here. So recast student J as a TeamMatePro, and then I have access. No, I've typed the wrong thing somehow. pawPrintsBalance. Oh, I have an extra, sorry, I have an extra. I left an extra close parenthesis after GPA. If you notice that and didn't do it, then it's not there. But if you have an error after typing that out, if you're following along, I left an extra close parenthesis there, which I needed to get rid of. So let's get rid of this. Let's comment it out. This should give us a table with all 5 of our teammates, all 5 of these students, but the ones that are pros have this balance, and I display the balance. If I tried to display that balance for objects that don't have it, I would get a compiler error. And obviously, to distinguish between teammates and teammate pros, I need to do a little bit of if-then logic to test to see what type of object they are. And so the syntax to do that is get class and compare it to both of my classes to test and see which type of object they are. And then after that, I can use recasting safely to recast the student as the correct type because I defined the array to be of the type teammates. Okay, so stop screen share. That was activity 1. So the only thing I want to do is give you a little bit of a preview now of what we'll be on to next time. So the idea next is to move our pizzeria point of sale forward. It's missing some features. Management says it's missing some features. So pizzas are great. They have a lot of stuff. There's the UML for pizzas as we have it right now. This is what we've worked on. We worked on Tuesday. But management now says, well, we need a product image. Customers want to know what our pizzas look like. We want to be able to use that in advertising, in the point of sale, whatever the case may be. We need images of our pizzas. And you can complain and say, no, our pizzas don't look appetizing. We don't want that. But management is firm. We want product images. We want a status code so that we can keep track of, like the Domino's pizza tracker does. So we know, for instance, our case, is the pizza being made? Is it in the oven? Was it dropped on the floor? What is the current status? We want a code for that. And then our customer is sometimes kind of picky, and they want to have special requests. They want to be able to tell us stuff about that pizza that they want done maybe slightly differently. So we want a string field to capture this special request so that each pizza on the order could have, if it made sense, or if the customer wanted to have a note attached to that said something like, I would love this to be a bit crispier, or please no boot print, this time, whatever the special request might be. And we've decided that we don't want to add those features via making changes to pizza. Pizza's already working. Our point of sale already uses pizza. We don't want to start changing stuff that's in pizza because it could break something in current point of sales. So instead, we want to use inheritance, both because it does make sense in this case to do it that way probably, and that's what the chapter covers. So obviously that's what we'll do as an example. So next time we'll create a new subclass called Pirate Pizza. And Pirate Pizzas will get the additional stuff. So they'll get, you can see I've got the UML here. Here's pizza. Here's our new subclass that we'll create next time. And it's got an image. It's got an integer status code, and it's got a string special request. It's got a new get method, which is get set status as string, so that we can convert between, say, status to and in the oven. For a point of sale or for our email blitz or whatever we're doing with that data, we want a text version of that code. And then I'm going to update toString because now I want to be able to describe the Pirate Pizza objects with that additional information, just like we just did with TeamMatePros. So toString will be amended in a very similar way as we just typed in, 2 minutes ago. I mean, it just obviously, since I pointed out here, let me say, when I provide toString down here in the UML, you might notice, wait a minute, that's exactly the same as this. There's no difference in the data type, the method name, or the return value. It's exactly what we have up here. So that's okay. That's an example of overriding. What we're saying is Pirate Pizzas have different data, and so their toString will be written differently to present that additional data or revised data. So it is meant to replace toString so that Pirate Pizzas get their own toString, but we're not changing Pizza's toString because they don't have those additional values. So they need their own toString. And if we do this right, it'll make doing the kind of thing we just did with Teammate and TeamMatePro actually much easier. All right, we will dive into actually doing this next time. So that's where I wanted to get to today. Thank you for listening and following along. I'll see you guys next week. That's all I have.